Hi, I just can't help myself. It's experimentation time again. Greetings, the Astro 30 here yet again, and I'm going to build one of these projects out of the 160-in-1 project kit that I used to do in the day. This was the main go-to circuit that I always built because I loved playing with it. It's project number 2 and it's called the Big Ear. So there's the schematic there. Now they're using the output transformer to connect the speaker to, the loudspeaker, to make that a dynamic microphone, to step it up to a higher level into this high gain stage known as a ring of 2 amplifier, or ring of 2 circuit as they call it. Now I have tried to look that up, can't find any relevant information on it, so for now we'll just ignore what its semantics is. Now it uses 2SA and 2SC transistors. These are 2SA 733s, and this one is a 2SC 945. Now I don't have either of those transistors, so I'm going to be using BC 556 respectively and BC 546. Now onto those pinouts, I was incorrect when I was speaking in the other video about the IC that I was remaking. It's always been collector base emitter. There is probably an obscure version of the BC range that does have it the opposite way around. I was getting confused with the 2N3904, 3906. They are emitter base collector. Anyhow, you could use either of those two transistors, the 2N range or the BC range, in this circuit, and it should work fine. They've got this 100 ohm resistor which is on the negative battery terminal going through this capacitor. This is basically a decoupling filter, a DC decoupling filter. Because this stage is such high gain, the propensity for it to start oscillating when it's at high volume levels into this output stage, it can tend to oscillate or motorboat or things of that nature. So this is done in order to try and separate the high gain stage from the output buffer, basically we'll call it. And this is done in a lot of RF applications as well, to separate the RF section from the audio section. It's quite common. They've got an input transformer over here, or the input transformer on the kit, going to the crystal earphone. Now what I used to do was, I did actually build the circuit up the way they described originally, and then I thought I'll modify it. I'll swap the output transformer around with the input one, so the output transformer is now driving the speaker on the output, put the input transformer down here, and then put an input on that transformer and turn it into an amplified speaker, which is basically what it turned out to be. That worked quite well. So I'm going to do the same thing today. I'm going to build it the same way I built it back in the day. Now the transistors I'm going to be using probably will not produce the same amount of gain as the original circuit did. These had a HFE of roughly 200, and the BC 556 has a rough HFE of around about 110. So there is a significant difference in HFE, or voltage gain, of the two transistors. So it might not be as loud. The other thing is that this circuit is using a positive common. So the input is common to the positive, the 50k pot is common to the positive, and well, the output transformer is also common to the positive, but on the output it doesn't really matter if that's going to positive. It makes no difference to it. What I want to do is I want to experiment and see if I can switch the negative lead, or the counterclockwise position of the pot, and move it up to the negative rail instead. I also want to try and do away with the transformer on the input altogether and put the input signal directly at this 100 nanofarad capacitor and reference that to the negative rail as well. Yeah, so let's get to building this circuit up and see how well it works. And just before I start, here is my redrawn schematic with the changes that I'm going to do to start with the input and output transformers, just for reference. So the other thing I'm going to change is they had a 47K and a 100K in series here between the emitter of the second transistor and the base of the first transistor. That's only because they were limited. They wanted around about 150K and they didn't have 150K on the kit. Probably would have worked with just 100K, but I've eliminated one component by making it 150K and it should still work just fine. Okay, so I've basically got the ring of 2 amplifier stage built up here on the breadboard. Here's my input transformer, there's the decoupling capacitor, decoupling resistor, there's the output transformer. As you can see, I'm using a different breadboard and the connections are really tight, so that's schmick for that. What I want to do is I want to actually test that this transistor stage is actually working before I proceed. Now I've got my oscilloscope connected to the negative common and the output of this capacitor, which is 10 microfarads. So I connect the battery and we can immediately see on the scope screen here that we have got noise, and if I touch one of these input leads we can see that we're getting a signal, so the blurt test is working. Anyway, I'm going to connect it up to a signal generator, which I'm going to just use my laptop for this because, yeah, laziness. I'm just going to use a online tone generator. Now we're picking up a bit of noise. Hopefully when I ground the plug, well, no. Okay. As we can see, it's fairly distorted, so let me just change. That's very noisy. Okay, let me go get my proper generator. Okay, I wanted to be lazy, but that didn't work out so crash hot. So, still receiving a lot of noise. Although that's a better looking signal though. Albeit it's square wave, that's probably because it's distorted to hell. So I've put it through an attenuation pot. I mean, I am getting an unclipped signal, but I am actually receiving 5.7 volt peak to peak out, so that's quite significant. However, it is a little bit on the noisy side. I'm not sure what the exact issue is here, but yeah, it's mostly picking up a lot of noise. It could be the capacitance of the breadboard here, I don't know. However, also so far so good. The input stage is actually working as it should, even on a battery that's only got about 8.2 volt in it. So now what I'll do is I'll build the second stage, which is the final output stage, and then we'll come back and test it. Okay, a short time later and in between doing other things, I've got the second transistor, or the final transistor stage output thing, transistor, whatever you want to call it. We're going to call it the output transistor, connected up, but it's not actually connected to the front end yet. I haven't got a pot in there. All I'm going to do is I'm going to test the output transistor, make sure I'm getting an output. So I connect it up. You can hear noise coming out the speaker. I don't know if you can hear that buzz, but I'll connect up the oscillator. And indeed, this connection is still a bit dicey, but okay. Shut that up a second. I'm going to connect my oscilloscope somehow around this tripod directly to my output leads and hook up the oscillator again. Well, it's outputting, yes. It is outputting, but it's pretty bad. That's because, well, it's distorting. Shut that up now. Okay, so what I want to do now is disconnect the battery and now I'll hook up the potentiometer in line with the first stage and see what we get. I really do not have a lot of room on this desk, but not with the camera. Now I've got the potentiometer hooked in. I've made it easier on myself. I've actually wired some fly wires onto it. So I'll just connect my positive battery lead up again, make sure that's turned down. Nothing unusual. Don't appear to have an output, so let me connect my oscillator up to the input. Oh, it does work. Now as we can see, it's clipping bad. That could be the input stage clipping actually, but it is only giving us about 0.42 volt out, so that is not very brilliant, but alright. And if you don't have shit all over the desk, you're not doing any work. Alright, I've connected up my laptop. Okay. Yeah, that sounds absolute crap there. Alright. Okay, that sounds distorted as hell. Okay. I might take this transformer out of the equation altogether. That's a bit better. But I think this battery doesn't have enough oomph in it. Okay, I need to change that capacitor because it's really not that great at passing audio. There you go. Alright, I'm going to try a fresh 9 volt battery. Yeah, it doesn't seem to have as much gain as I remember. Okay, I'm going to change something here. I'm going to reference the control now to ground. Okay, well that does still work. Cool. Okay, I'm just checking the output maximum swing. It is relatively clean with a lower input, but I'm getting at the point of clipping only about 400 millivolt peak to peak, which is not a great deal. As for what is going in, that I'll have to find out the hard way. Where's my signal in? There. I'm only putting about 10 millivolt in. I went back to the 100 nanofarad input capacitor because it sounds tinny, yes, but it doesn't like passing a lot of bass. Most of the distortion's gone now, which is quite good. Let's see. It is driving to painful levels. Okay, so the original circuit had 100 nanofarad ceramic. Now, I just want to make a quick low pass filter here. Okay, I've added a low pass filter in between the center point of the pot and, well, this input capacitor here for the final stage. I've also put the speaker in a little cardboard box over here. Take this capacitor out. See, it is rolling the highs off. I did try putting it at the input, but it just caused the thing to oscillate when you turned it up full. So what this consists of is a 2K2 resistor and a 100 nanofarad capacitor. And that just rolls off the harshness of the highs just nicely. Right, and to conclude, my theory was correct. It could be modified so that we now have a common negative rail to the input, and not necessarily the output, but at least to the pot and the input. And all I had to do was just move 2 wires, and that transformer was pretty much, well, useless on the input, so it had to go. So those are my changes. There's this 1 mega ohm resistor here that just sets your input impedance if you so wish. Mine had 150k across it, and it didn't really make that much difference to the circuit. The output transformer is still referenced to the positive rail, but that's fine because that's giving collector current to the BC546 transistor. Now, if I'd used the original 2SA and 2SC transistors, I might have had a little bit more gain out of it, but that's just what happens. It does work in this configuration, and it works pretty well. So that being said, notice here I've put LPF. Well, that's in reference to this extra 2 components that I've added between the volume control and the input capacitor to the base of the BC546. It consists of a 2K2 resistor and a 100 nanofarad capacitor respectively, just to roll off the highs a bit so it doesn't sound so harsh. You can choose to add that if you wish or not. I did have a test point 1 here. I was actually meant to measure what voltage I was getting here, but I ended up forgetting. I'm not sure if it's going to be at roughly half the supply voltage, but for what this is at the moment, I don't think it's really relevant. This 100 ohm resistor could easily just be up here on the positive rail, and it will still work as a DC bypass from this output stage to the high gain input stage. This dotted line here representing a resistor was not important, and it's not actually needed or necessary. So we ignore that, don't bother adding a resistor there, because if this circuit is working fine as it is, leave it alone. So I found out that the maximum input before clipping of the input stage is about 10 millivolt, which is quite small. So this amplifier will be more suited to amplifying really weak signals like that coming off of a crystal radio, for instance, or that is the detector diode of just a simple tank circuit and tuning arrangement to pick up AM radio stations. So there'll be enough gain there for that. It won't drive the speaker to painful levels. I was only getting around about, I'm going to say 500 millivolt peak to peak, and if I do the calculation on that, okay, so we've got roughly 250 milliwatts multiplied by itself gives us that divided by what our impedance is. Yeah, we're lucky to get 7 milliwatts out of it. It's pretty low. But for a small transistor radio, it's probably perfect. So that's it. I'm going to leave it here for this one. I hope you enjoyed it. If you did, please remember to rate, comment and subscribe below. You can always follow me on Facebook, and you can become a Patreon supporter for as little as $1 a month. I would like that very much. Anyways, this is the Astro 30 saying, see ya, have a great day.